All right, so we're going to try it a few more times, looking at more exercises from the book. So what I've written here now is in the same set of exercises, exercise set 2 from 5.5, and this is number 3 from that exercise set. So let's work through this. So same procedure, make the conclusion false underneath the main operator. How many ways are there to make a horseshoe false? Just one. That tells us that P must be true, S must be false. And then we plug those in across here as we find them. So S is false, P is true. All right, next step, make all the premises true underneath their main operators. Like so. Start with the easiest premise now. Well, let's see, we're right here. We've already got some information. S is false. If we want this horseshoe to be true, should we make R true? No, right? If we made R true here, that would immediately, we'll say, contradict what we're supposed to get here underneath the main operator. So R must be false, right? We can pin that down. And anytime we can pin down one of these values, of course, that's a good thing. We're getting closer to finishing the problem. So R is false. R is false. Here, what do we have? Well, right here, we have P feeding into the horseshoe from the left, and the dot, right, feeding in from the right. So we're looking at true horseshoe something that's going to get us true. Well, if we want true underneath the horseshoe, and we've already got true over here in the antecedent position, the dot is supposed to be true, right, to make that happen. The problem is we've got false feeding into the dot right there. And anytime, and you'll remember this, right, anytime there's false feeding into the dot, you don't get true under here. In fact, it doesn't matter what Q is. It doesn't matter what Q is. Sorry. Whether Q is true or false, this will not end up being true. And so, in fact, it doesn't work. We can't get that main operator to be true. So we can return to the handout. And what the handout says is, well, step 6, continue until you're able to make all the premises true or you get a contradiction. Well, we got a contradiction. And that's how I indicate a contradiction, by the way, is by Xing out the main operator value that doesn't work out the way we want it to. So, step 7. If there was more than one way to make the conclusion false, well, was there more than one way to make this conclusion false? There wasn't, right? So we can skip step 7. Step 7 only applies when there is more than one way to make the conclusion false. So we'll get to that on the next problem we work on, I believe. So finally, step 8. If you are finally unable to get all true premises and a false conclusion, the argument is valid. So just make note of this, right? We got a contradiction, it didn't work, and in that case, we say that it's a valid argument, right? We have shown that it's not possible to get all true premises and a false conclusion for this particular argument. And if that's not possible, well, that's what we mean by valid, right? That's what makes something a valid argument. Okay. Now, one little warning here before we end the video, and then I'll write down another problem here. But one little warning is this. Depending on how you feel about validity, and people have different feelings, I suppose, around valid and invalid arguments, but I want to make a special warning to any of those of you who are sort of, we might say, get excited that a particular argument might be valid, right? Hooray, it's valid. And I can understand that feeling because, you know, we could all hope for more valid arguments in this world. But I want you to notice something about this technique. When you work through indirect truth tables to determine validity, when it doesn't work out, right, when we get a contradiction like this, what do you know? It's a valid argument. On the other hand, as we saw on the other problems we've worked on so far, when it does work out, when you can get all true premises and a false conclusion, right, everything works great, it's invalid. That's the result we get from that application of the process. So to a certain extent, this indirect truth table technique is a little bit, as I describe it, emotionally backward, right? We get a problem, valid. We don't get a problem, invalid. So just be prepared for that. It's fairly common, actually, for me to see people who know how to do the technique just fine, but then when it comes down to the last step in terms of labeling the result, they actually get it reversed because, emotionally speaking, I guess, it feels right to say one thing when they should have said the other thing. So just keep that in mind. And also, I'll just note here, when you do get a contradiction, this is how I indicate a contradiction. That makes sense to me. Of course, Hurley, the author of the text, would indicate the contradiction by circling all of the values that don't work, essentially. And if that makes more sense to you, you can indicate it that way. However, whenever you have a valid argument, I will need to see where you find the contradiction, right? And you need to indicate that and make it clear. This is a good way to do that.